么先？啊，没有要什么方向？那我是建议你不要拿 regression 了。什么？那聊啥？对，建议还是不要拿 regression。对对对。干嘛？那你换 rim 了？哎，给你看到坏掉，你知道吗我真的打野。你换 rim 然后你又就是他讲那种他比较少选择。那你打野吗？我还是换打野啊。然后问题是我的 rim 可能是撞过洞，你知道吗？他就来还有一人人啊，对，他是说来里面歪掉，不懂。相信是有，因为确实我的那个 steering 会这样，然后嗯，然后打压就很快的这样子，一定还可以再久一点，现在才3万，还不到3万，他那个打压已经平了，正常3万就平了，但是还没有到3万，所以2万多，可能他就是不平均，然后弄到好东西我不懂，不，就是也有那个 steering 的问题，加油路啊。确实呀，应该的，他不要去一动。招生，你可以认真考虑一下。不过你可能也要考虑一下小心脏啊。考虑一下什么？他 A 班来怕么？哦，你要小心脏。你小心脏还好吗？啊，对。那我是点短。哎，看起来像眼睛一片想法。哦，几万我有点馋了，不长。这个我给你传。对了，一百打断，可以头痛吗？哦，Hello. Let's wait for a few minutes. Uh, wait for the others to come. เราไม่ค่อยควรเสียงกัน Maybe you should start. Where's Larry? Hả? Tụi mình đây. Hả? Ồ, người là vô rồi. Em bữa nào là
没有，我那时候很菜。
看错啊。We should get some master students. Okay. Right. Good morning to everyone. Welcome to General Topology. So this course is a pure maths course, so you expect a lot of proving here. Actually, we are quite happy to start this class. There are two beloved batches of students here. My 2304 and 2309 are both here. Good to see you guys again. And we have master students with us for this class. So this is the ME class. You will be having classes with the masters. So basically, I'll treat everyone the same. Okay, but what's different is your assessment. That's all. Okay, all of you will be learning the same stuff. Okay. A lot of students will complain to me that before that, maybe most of you know me already, but for those who don't know me, I'm Seng. Okay, you can call me Seng. You can call me Seng. And a lot of students told me that maths is hard. Yes, sure, maths is very hard. But I think all my students have gone through at least 15 weeks with me, and then I think they get some fruit, okay, from learning pure maths. So I hope you will also learn something new, okay, after you graduate from this course. Right. So speaking about maths is hard. So why I'm happy here because I think this course is about 29 students already, okay, including the masters. This number is actually very encouraging. Very encouraging. already because we are almost the same number as a normal class already. So I think we could achieve more in future. And then we could push the general topology into a proper measure called cost in future. Yeah, because general topology is really a basic. Okay, yeah, not so advanced yet. But anyway, in Malaysia, maybe it's quite advanced. And also, another happy thing is in our class, I think we got like 1/3 of females. Female is very important here because there's one students come into my class is that you think us the first time I taught general topology, they're all males, no female, zero female. But this time we have 1/3 of them. Okay, so it's not that female cannot do it. Okay, you can do it. Right? Yeah, female can do max. Okay. So what do we have in my class? So these are the four things, four principles I want you to remind yourself. And maybe sometimes I forgot, you can remind me that our class focus on freedom. Okay, you can freely discuss, okay, freely learn, okay, knowledge in this class. You can discuss assignment among your peer. But there's one thing you need to remember that you cannot copy, okay, plagiarism. You can discuss ideas and then write down in your own words. And then remember to write down a collaboration statement if you work with someone else. You say that I work with this guy on this question. Yes. Okay, yeah, sure. Okay. And then third, about rigorosity here. So in my class, right, there's almost no jump step in my class. Okay, if I jump, you can question me also. If you jump, I will take off your marks. Okay, as easy as that. So we try not to jump step. Okay, write down as clear as possible. This is advantage that maths can do. Okay, we try to make everything rigorous. Okay, step by step. And then last one is clarity. So clarity is not just about your assignment presentation. It's also how you speak, how you present your idea. Okay, clarity. So in case you found that my explanation is not clear enough, you can question me, you can ask me. Okay, don't take my word for granted. Okay, or don't just believe whatever I say. Okay. Yeah. All right. So I think let's go to assessment first. So where's my assessment? Yeah. So basically, if you are enrolled, you can look at Moodle. Are you all in the Moodle yet? Please make sure that you are in the Moodle. If not, you can email me. Okay, so you can go to the Moodle. So I put out textbook that we frequently refer to, and then some other references. If you found that this textbook is not understandable, so there are all references for you. There are three sections here. Announcement is for me to make some holiday announcement or any changes or any assignment result, tests, so on. Student forum here is for you, okay, for you to discuss. Actually, you can post your question and the other student could help. Okay, maybe I mean in Asia, right? I mean not you we would think that if we help people, maybe we want to get it to the right place, the correct answer. But really, sometimes in academic, right, there's no absolutely right or wrong answer. What's matter is the logic. Okay, what logic you use, okay, to reach your destination. This is very important. This is true even in the paper, writing academic paper. It's true also. How do you know that the result is false, correct? As long as your logic makes sense, then it's okay already. Yeah. So logic is very important. And then the third one is you can question me here. Okay, if you put some question here, I will answer you in class or inside there also. Alright, so this column is specifically for me, and then students forum is for you. But for my past experience, MAT students still don't use this one. Yeah, they put 0 question there. Empty set. And we will learn about empty set today. So yeah, there's nothing there. Huh? But nothing. There's no element. Okay, so there's nothing there. But fortunately, when I go to GE, right? GE, for example, I just finished last GE on a linear algebra. There's at least one student ask a question there, but no one answering the question. Yeah, so at least one. I mean, in GE, it's very interesting actually. GE, although they are not a max major, right? They are very interested. So they are sometimes even more passionate than MIT. Yeah. So well, I mean, it's okay. I mean, you can freely use this platform here. So I put resources here, some very important resources here. So I have put my first time when I taught general topology, the lecture notes. So more or less we will uh, follow the order here. And then there are two versions here. There's a typeset, like what we did for abstract algebra. This typeset is done by a master student, Wen Chuan. Okay, Wen Chuan. So I think this year, I think we're gonna improve it. Is it?
Yes.
Yes. Okay. So Eric already volunteered before the class start. Did you volunteer? Yeah. Okay. Okay. He volunteered. So if you are interested with typing these things, right, my notes, because usually I just write it down and then I just share it. So if you're interested in typing, you can contact him. I think he need a lot of helpers because
How do you have another class?
okay, one thing is I have another class. The other thing is I put a lot of homework questions inside there. So maybe you should do it, okay, during this test set. And then maybe you need to draw a diagram also. Okay, so okay, so you can talk to me or talk directly to him, and then you guys can figure out how to distribute the works to type it, because I think they are quite experienced already in typing the notes. Okay, we have AA notes done also for last semester. Okay, and then I put out the past year lecture recording also if you need it. And some other note. Okay, the other note is about from Prof. Teo. Prof. Neo, there's a one advantage. So she arranged this topic very, how to say, very organized. Okay, so if you miss something, try to miss something, you can go back and check the note what you miss. Okay. Maybe one thing that is not how to say, not very satisfying about this note is maybe there's no extra explanation here. Yeah. But the proof here will be very succinct. I mean, what she did is, I guess, she read a lot. Okay, she read a lot, and then she picked out the most efficient proof. That's all. Okay, so this is something that you can learn from. Okay, but from my class, you should learn something else also. Okay, how to explain your idea. Very important. Okay, yeah. So they are good or bad, okay, to everything. So not everything is good, not everything. Okay. Yeah, all right. So similar to last time, right? The main textbook for this course is Moncrief. So we have a solution manual here. Is it solution manual? Let's see how. Yeah. So this solution manual here is done by someone else also. Okay, I'm not sure it's complete or not. Okay. Maybe if some of you want to start doing these questions also can. Yeah. If you want to do it also can. We can discuss. But in this course, right, I prepare another set of tutorial sheet for you also. Okay, so I already put it out. I don't need to hide it for you. I even put the solution to you already. I believe you are adult, right? You can try and do and then refer, right? Not just copy. Yeah. Okay, so this tutorial sheet, right, quite related to your assignment. Okay, so you can do tutorial first and then do assignment. Okay. I think we won't spend a lot of time discussing this unless after you do it, you think that didn't make sense, and then I can try and bring it up in my class. Okay, so later I will explain again in my class how things works. Okay, let's talk about assessment first. So since I talk about assignment, right? So let's see the assignments. So there are actually 40% for your assignment, 20% for test, and then 40% for final. Okay, wait. Let me wait. Okay, so 40% for assignment, 20% for tests, and then final 40%. But if you are a master student, right, you don't have tests. Okay, what you have is a project. Later I'll talk about what project you should do. It's also 20% also, okay, including your presentation. How many masters are here today? Can you let me know? Can you introduce yourself? What's your name? Okay, so what's your background? Like where are you? Where you came from before master? Where do you do your bachelor? I see. Okay. Any motivation you came to learning pure maths?
Through the syllabus and then like quite interested.
Okay. What are you going to do in future? Do you have idea? Lecturer. Okay, good. Hi, what's your name? Oh, Jung Han. Okay. Okay. MAT, yeah. So you never did general topology before? You did, but you retake it? Or what? Are you allowed to do that? Uh-huh. Oh, okay. Who was teaching you last time? Prof. Teo, okay. Maybe you experience very different things in my class. Okay. Yeah. Okay. Hopefully you learn new things. Yeah. Okay. Since you are doing second time. Okay. So okay, for this assignments, in this class you don't have project. So we split it into assignments, 10 assignments. Okay. We split into 10 assignments. So this is a weekly assignments. Every week we need to refresh what we did. Okay, and then for this course, actually, it's very good to do every week because we have little short section technique that you need to learn every week. Okay, so make sure you learn. So how do we define this short assignments here? I try my best to give you almost 3. Okay, question almost 3. Okay, I try my best. Okay, I try my best. So the timeline is like this. Okay, timeline is like this. So basically, starting from next week, we will have assignment 1 due. So basing on this week, okay, and then week 2, week 3, week 4, week 5, week 6, and then we have a break. Okay, you can do revision for tests, and then again we will start weekly assignment. Okay, and we will end at week 14. Okay, actually, we will end our assessment earlier than almost all the other courses. Okay, although we have a lot of assignments, but we will end earlier. Because what I'm going to tell you is there are 5 topics we're going to cover here: set theory, topological spaces, and continuous function. Okay, so the very important example here is metric space, which you will see a lot in your MA2. And then third is connectedness and compactness. And then fourth is countable and separable spaces. Fifth is complete metric space. But from the last class that I thought this topic is really coming out from in the final. Okay, so basically you spend a lot of time in the first 4 topics. Okay. Yeah, you will spend more time in the first 4 topics. Okay, so this one is I think rarely come out in final. Okay, we'll see how it goes. Maybe you will get shocked a bit with this weekly assignment, but let me tell you, this is very natural in our university actually. In the university that do pure math, we have weekly assignment, almost like a weekly homework. Do you have homework from Darren class or not? You have? Not yet. I haven't tell you. Or maybe I can disclose to you first. It's a weekly homework. Okay, they call it. 是吗？是不是？we got friends. Yeah, you got senior behind. Yeah. Homework but I call it assignment because I want some independent work from you. Okay, maybe slightly mention about master's assessments here. Maybe we can repeat it again when we go further in class. Okay, so basically the idea for the master is I want you to pick a topic from different field, okay, other than topology, but you actually see topology inside. Okay, for example, what field? For example, in differential equation, okay, how do you prove that there's a uniqueness and there's an existent solution here? Actually, you could use topology. Okay, and topology also have a relation with number theory. Okay, you can define a topology of numbers. I think there's some masters doing physics, right? Coming from physics background. You can talk about physics with topology, for example, string theory. And topology and analysis actually there are wide topic here. I just put one of them here. Maybe one of them is a loop integral. Actually, this loop integral you will see in complex analysis also. Towards the end of the complex analysis, actually you will see some part of algebraic topology. When you do control integral around a singularity. And topology and algebra also, there's a lot of topic, but I choose one of them here is category theory. Okay. And topology and category theory itself, okay, category theory can extend to abstract, very abstract ideas. So maybe you can talk about category of topological space. And topology and symplectic geometry, maybe you know about this. Then you can do fiber bundle. And then with group theory, maybe you can do some group action. Representation theory, knot theory, algebraic geometry. So this algebraic geometry, right? We have another course. Okay, will be on Monday, Tuesday. We have reason this week. Hopefully, when we do some singularity, we can see some topology there, but we're not too sure yet. Okay, and then if you take some functional analysis, one thing I know about this, the connection is Jones polynomial. If you want to talk about this, because my background is on the knot theory. Okay, I work on knot theory, so I know this connection. Obviously, there's other connection. Okay, you can look for it, and you can look for other cases. Okay, that you're familiar with. Okay, then you should find some topology there. So it's not very rushed yet for the master. Maybe starting from next month, you can come and talk to me what topic you are interested in. Okay, after you learn some topology first. And then you try and do some research. When we go along the subject, we will come back again. So the project, I will call it the marriage with topology. Okay, how to combine topology with the other field, and their presentation afterwards. So we can talk about format later. Okay, so since I put a rather heavy workload to you, right? So I will offer 4 hours office hour per week. 4 hour office hour per week. One thing that I did very successful last semester with AA1 was we have a office hour book in the meeting group. So basically every week they will come in and do assignment. And their result, I think, is significantly better than whatever batch I teach before. Okay, so do you think that it's necessary that we do it again? Okay, okay, sure. Okay, let's do it again. If we do it again, let me see what's the will you come or not? Will you come and do assignment? You'll come to play. Because if not many people come, I try not to book a room. Maybe you just come to my office, it's okay. Yeah, if a lot of people want to try and study together, then we can provide a room for you. What do you think? Meeting room. Okay, so let's try let's try a few weeks first. Okay, see how it goes. If there's no need to book a big room, then we just go to my office. Because now my office also got a whiteboard already. Yeah. Yeah, try to sell my whiteboard. Okay. Okay, so I mean, wait, let me see. See what's the timetable. And what's your timetable? Okay, so this is my timetable here. So my suggestion was, how about we do Tuesday, Wednesday, 1 to 3. Are you guys free at that time? Tuesday, Wednesday, 1 to 3. Not free. Okay, so you mean this oh okay, so Wednesday not good, huh? Tuesday? Tuesday 1 to 3, okay. Okay, Tuesday 1 to 3. And then how about the other day? Thursday, Thursday 1 to 3 also? Huh? Thursday 1 to 3 before the class. What do you think? Not good. Okay. Top class. How about Thursday? Thursday, anytime you can do. Other time. Oh, you got for class. Okay. Huh? Others, Huh? No. So how about Monday, Monday? Monday, what time? 3 to 5, Monday, 3 to 5 is not a very good time, because there's a seminar. The department seminar will go on here. If the department seminar is on, then maybe we'll cancel office. What do you think? Department seminar, there will be like guests or guests or the lecturer giving their research talk. What do you think? It's not every week, but if that happens, then we can cancel it. Wednesday, what? Wednesday, I think not to do at night, but sorry, come on. Oh, it's 4. I mean 4 o'clock. When is 4 o'clock? Which one? Wednesday, Wednesday 4 o'clock. When? What do you think? What's the time you want to suggest? What's the time you suggest? 5 to 7. Which day? Wednesday 5 to 7. Wednesday 5 to 7. Anyone interested? Adrian say after discussion can go dinner. Wednesday 5 to 7. Because you guys got a lot of classes. Wednesday. What do you think? You okay? You got class 5 to 7. Oh shit. Let's see. Other time or not? Thursday cannot, Thursday morning cannot. Hi, hello. I don't see.
Yeah, Thursday is 5 to 3.
Thursday 5 to 3 for you.
Okay.
Cannot. Some people have class, I think. Friday, Friday, there's some planning on Friday because I try to put my FYP on Friday because I got 5 FYP. So maybe I need 5 hours from here. And then this sem we got a research intern. Yeah, actually it's here. You want to introduce yourself?
Study pure physics in USM bachelor degree. So doing research intern with Topology.
Yeah, so 2 months. Yeah, for 2 months. So when he gave a seminar, maybe I can invite you guys to come. So we only have one time fixed on Tuesday, Okay, maybe we fix that time first, and then I fix my FYP and then we see how it goes. I still have another class to consider also. Okay, yeah. So let's fix Tuesday 1 to 3 first, and then the other time let's think about it again. I'll give you some choices again also, because it's not clear for me also for now. Okay, after I discuss it. Okay. So apart from office hour, right? I'll try to give as much hint as possible to assignment. Okay, so that you know where to start. Okay, instead of thinking from nothing, give you as much in hint as possible. This proven works in my calculus 2 actually. Last semester my calculus 2 is the first result that I never need to scale, and it produced a very good result. Very good. Huh? A little, maybe 5 marks like that. So we're working towards non-scale result. Okay, without reduce the water. Okay. Okay, so I think this is for assessment, right? So I think in this class, right, most of you are good students. You should know what to focus, right? You know what to focus. Because the main thing you need to focus is actually your assignment. If you don't see it wrong here, because assignment is 40%. Okay, so make sure you do your assignment well. Okay, then you won't pass, and then maybe you'll pass with flying colors. Usually my test is a little bit harder. We will do what's that? Cheat sheet also. Well, for this test, we will do cheat sheet also. Although the master didn't do test, right? I recommend you to come and do it. Okay, when they do test, you also come and test yourself. Okay, but it's not recorded. What happened to master is all the subject here will be tested in final. Okay, so maybe you will have some extra question more than the undergrad in final. Or maybe the difficulty will be harder. Depends on I'll see what's your standard. Right.
That's monthly, or
Yeah.
do this multiple projects.
I try not to offer this option yet. Okay, I try not to offer yet. Try not to offer. Try not to offer. Only you want to do it. Yeah. Try not to offer the project option yet. Because I want to train your hard skill actually. I want to train your hard skill. So meaning proving doing question like that. Because you have other project to do, you have a MA project to do. If you take algebraic geometry, you definitely have a project to do. Because we designed that course as a master course, like a master course. I try not to offer a project option to undergraduates because I think the pure maths foundation here is not as solid. Because you only did MA1 and AA1, that's all. And so I think it's better you prove more first. Then your foundation will be better. See how it goes. I'll see how it goes. For future, I cannot say for sure, but for this class, let's do assignment first. Okay. Anything else? Need to update you. Right. So for my class, right, it's not fully lecture. So fully lecture means just me speaking. Okay, but you can speak also. Okay, definitely you can ask me. So it's like a lecture plus tutorial. Okay, sometimes we'll take some question and discuss here. I might get stuck also. Okay, because I also work from zero. Okay, you also work from zero. Then you will learn how to get unstuck together. Okay, and we break the idea that we present in class into about 7 categories. About 7 categories here. Okay, so you need to be sure what am I talking about. For example, I will start with motivation first. Okay, almost when we talk about new ideas. Using motivation or question or observation or some intro or recalling something that we learned before or some history. Okay, to bring out the new subject. And then second is very important definitions and axioms. Okay, I think all of you that have come to my class experience that how important is definition and axiom is. Okay, so anything you don't know must go back to definition. Third is examples. Okay, examples, non-examples, because why we come up with this definition, actually we have these examples in mind. Okay, so whenever we talk about definition, you must have some example to work on. Okay, and also I'll put some exercises homework, okay, for you. Fourth is after definition, we will prove some statement which we call theorems, propositions, lemma, corollaries. Corollaries follows from theorems, proposition, or some claims, okay, that we will prove. So proof is put in almost we put in a blue color. Okay, so how many ways to prove? Basically, there are direct proof, contradiction, contrapositive. So these things you should know. And six, we'll put some remark. Okay, so remark is like we explain the idea or how we think about some ideas. And maybe we'll introduce notation here because mathematician lazy to draw sometimes. I mean, to write a lot of words. So we just use symbol. So we introduce new notation. So notation is very important. If you don't know what is phi talking about, actually phi is empty set, for example. So you need to recall. Then notation, terminology, maybe new terminology, and then give you some remark, and then upshot punchline like that. It's equivalent. Tell you what's important. And maybe I'll put some warning here because maybe a lot of students will did mistake or have a wrong thinking. Very easy have a wrong thinking about some concept. I'll warn you. And seven is some other comments and some philosophical thinking when we try to learn this subject. Some subjects, okay, then I'll let you know. Or I'll lead you to some advanced stuff. Okay. So why I split into colors here? Because this will hopefully will ease your revision. Okay, because if you want to look for proof, you just go to the blue color. Okay, if you want to look for example, just go to the green color. If you want to look for definition, just go to the white color. Okay, so this is the reason why I split. Okay, if you imagine if I don't split everything in white, then you will like get lost in the wood. Okay, yeah, very easy get lost in the wood. It's not for you. Okay, any question? So I speak for half an hour already. Any question for you? Know how to do? Know how to pass this course? Know how to pass this course? Okay, so passing this course is pretty important. And if you want to get good marks, also very important. Yes,
I refer to this video.
this video. Yes. So, okay, this video I will put the link into the Moodle. Are you in the Moodle? Yeah. Hey. Oh, right. I just get your name this morning. Okay, I will add you into the Moodle, and then we'll put all the course information in file inside there, and then I'll put the link there. Okay, actually, it will link to my YouTube channel. So if you don't have the link, also you can update. You can see the update in my YouTube channel because YouTube is a free storage, right? Free online storage. Okay, so okay, I will add you in. I just get your name this morning. Okay. If no question, right? How about we take a break until 10? Yeah, so basically every hour we'll take a 10-minute breaks and then we will continue until the end for the second hour. So let's break until 10:51.啊，有东西吃？怎么会有东西吃的？还有外人在吗？
哦，master，对啊，理论学生你应该都教过吧？
嗯，
按摩。
哦，多少星？
Can actually, I mean, how to say? I mean, when
Not in the
yeah, I actually cannot add you in, because you don't have the XMUM email. So I mean, what we can do is I actually have past year notes inside my website. Maybe you can download there. In my website, I cannot add you in Moodle, unfortunately, because you are not SMUM email. You can go to my teaching.
如果你放封面，有什么？
Maybe later we talk about yeah, meetings. Hey, 哇，谢谢，什么来着？
我小板，我要吃你啊！
没事没事，谢谢。
吃早餐，
我们还没吃呢。
有人也没吃早餐，我也没吃。来了大学就不想吃早餐，不吃我会饿死的。等一下。啊？找到吗？可以想一下。哦，有一个人给的鸡饭店，你们没有吃过的？我上学期一直去吃。
这都跟你去吃多少次了？
啊，他有啊，有，他是干捞的，不知道有汤吗？好像有汤，他也有怡宝米粉啊，那个还可以啊，还可以。是
如果我们12点下课去吃，会不会都已经没东西了
12点有了，12点半。
之前我们12点去就没了。
1点比较夸张。
我感觉我们之前12点去就没了。
然后
挺好的，你多操过以后，我工作就量就少一点。我说你多操过以后，我工作量就少一点。
OK，
对呀，
发现我讲话的好处啊。
Actually, well ordering，
为什么
这样很远，让我有点不相信。
？OK，
然后认识
可以讨论一下。
有什么 set 都好，
你可以做
connection，
Not in a.
啊，是
他讲，他看出来，我们是在表明上线它有最小的。
哦，
但是他都是提报，
都好多，如果他
That's not me。没有，我问了，帮你问别人。
不 comparable。他就是把它 order 到它可以 comparable。
我原本是要他讲那个 Isaac 啦，大家，我要讲那个省市都那个。Yeah，
上菜上快乐。
还有我还感觉like都很多。
take attendance 啊，活动。说你
很厉害，还是有道理，还一样。
金圣节
好的，
，Ivan 呢？Holiday 啊？
你要不要做 multiple design？
啊？还没有在点雷中音，雷中意小康
如果有
肉男渊若天金鱼小月红瑞佳怡瑞我心照美拉一烟
这就一定更灵魂，看得好就讲。
看起来的，
还可以看到。刘丽我们博的。我们跟人家 request 啊，email 反出来。
I guess 我们也可以从那个生命的美开始啊。搞精心。
不会分到其他那种种族哦。
对。
就是 cultural reference 不是？
你们要 specific 多一个。
你们有注定他没有违背的超级。
哇！
为什么？
这边。
哎，其实我有在猜，你知道吗？我还没有 zoom 到很 in。
你是什么？
对，我觉得有那种感觉。
你是要不要把那边发光一点？还有点不大。
对。
很亮。
是比较
你是你要不要放电脑？
他讲他会做那个猫哦，等一下。
那你就用 V 分先。
什么？
我喜欢 V Fusion。他猫要放中间还是放下面？我也不知道啊。我先放下面了。
画一个没有。
我想它在下面。
画一个猫巴士。
猫巴士。哎，他讲他的 idea 很好啊，你知道吗？他有放很多啊，蛮用的吧。
就是你们
有点延续我们上次那个 idea。
要死的是。
这个马来西亚的一个算华人嘛，传奇人物，
哪个的一个
他们的英雄，就是
你们觉得吧？那你
们打现在设计什么？
他设计那个 copyright。我之前不是放一个长城的那个，他要放兵马俑。
我们要把它设计成封闭啊，封闭
有必要？
有啊，我们都把它做成 book 了。
你来卖啊，真的。
对啊，我们都把它设，我们都
需要有钱，要有钱。
我觉得能卖。
是哦，要来卖。
对啊，拿来卖啊。
A1的时候就
这本书是没有。
You need to buy this book to get
没有 publisher。
如果你不买就给你废了。
然后讲 you need to buy this book。然后写30块，然后你可以一人收30块。
Lord。对，我就是突然间想，
也是突然间想的，
没有什么。
Okay, let's start. And before we start, I think we need some class rep here. So class representative. So what does this class rep do? Basically, you become a middleman between me and your friends. And so any reminder you come back to your friends about assignments or about replacement. Okay. Right. So actually, there's only one holiday affected your lecture. Okay, so I think we will try to make it into a midterm replacement. Okay, so we'll make that into a midterm replacement for test. Okay, so we don't need to do lecture replacement. And yeah, class rep. So I think I anticipate this group, this class right will have a very good study atmosphere because these two main group, right, 2304 and 2309, you guys will study together.
Actually, I visited both study group also. For example, 2304, you guys will study at D6, right? Lower ground. And then for 2309, they like to study in B1. And so maybe you guys can communicate, can try and combine also. Yeah, can try and combine, but learn from each other. But anyway, let's pick a class rep. Okay, can we pick a class rep from undergrad and one from postgrad? Because postgrad actually got 3 of you. Maybe picking one is good. Anyone want to be a class rep? And basically what you do, first job you do is you have to collect all the ID here. Huh? Yeah. Okay, 做过了，换人来换人，来换人。So, so basically the first job is you go and collect all the attendees here, okay, add them into a team group. Okay. Yeah. Anyone want to do? I want to be a class rep. Yeah. You don't suggest Eric. You don't suggest. Someone suggest you. No.
我已经帮你干的活够多。
Okay. 来，Jack 要不要 Jack？ 哎，
罗浩，
老号。
为什么不要？
哎，他都没有在。
他没说不要啊。
他不能说不要。How about pick one from master first? 来，佩仪 or 陈通 ？Don't be a class rep. Don't want to. 佩仪 ，don't want 啊？哇 ，like this very hard 哦。You guys 检讨指头部。Huh? You will care? Okay, can sure. Let's get one from undergrad. Right? Get one from undergrad. 嘉怡要吗？嘉怡，要不要做 class rep？基本就是你记得上次那个烧旗怎么做啊？就类似那种东西。啊？什么？什么？你是这样 OK 好，非常好，这样我们有一打一点。OK， so yeah， so before 你们今天离开啊 ，I think hopefully I can give you leave on time 啊，50个人 OK，so you guys give them your ID OK，then 你们两个 start 一个 Teams group chat， 还有 to start a team group OK team group page，and then later you can do announcement there， and then remind your classmate。I want to get one from master because I think you all should have the same study plan, right? So that you can stick together and then you can remind each other. And then similar for undergrad. Okay? All right. So, yeah. So let's start. Okay. So first chapter is set theory. I think you have to do a little set theory inside your discrete math class. But we're going to do more detail this time. Okay, let's do it. I will start it slow. Okay, my tempo is slow and then fast. Okay, I want you to keep in the same page what I want. Okay, how detailed the argument you should go. So basically, in our field, right, in mathematician field, what we call the theory that I'm gonna introduce soon is called naive set theory. There are more treated well set theory like ZFC and something else, the more Frankel set theory, but we'll do naive set theory here. Okay, so let's start with some motivation. So I'll motivate you using a Russell paradox. Any one of you heard about Russell paradox here? Yeah, so what's Russell paradox? Huh? What's Russell paradox? Anyone know? So basically, we build a set. Let's call it X. Okay, so this set, what's this set here? So this is all the elements such that X is not in itself. Okay, X is not in itself. Okay, all things that's not in itself. Not an element of itself. Yeah, so from here, we will get a paradox. So how do we get a paradox? So suppose x exists on this. So usually we'll use a dot equal to mean define. And define means I don't know about x, but I know what is this bracket here. Okay, this bracket here says what? Everything such that x is not an element of itself. Okay, not inside yourself. So suppose it exists, there are two things can happen, right? For set. Either x is in S or S is not in S. Two things will happen. Okay? Either you are inside this classroom or either you are outside this classroom. Not this classroom. Okay, very simple idea. Either inside, either outside. But think about it. If x is in S, what does it mean? You should satisfy the condition you define, right? Meaning what? Then we get S is not in S. Fair enough. Because since you are in this S, you have to satisfy the set condition here. On the other hand, let's say if S is not in S, meaning what? Then we also get S is in S. Why? Because it satisfies the set condition. Okay, how to stay inside this set? You just satisfy the set condition. So in both cases, you will get contradiction. Okay, in and not in, both true. So this both of them are contradiction. Okay, both give contradiction. Okay, because why? Because P and not P are both true. Because P and not P is true. P and not P are true, where P is equals to S. Okay. Okay, so if you have a statement is true and the negation of statement is also a true contradiction. 对不对? Correct or not? You cannot say you 很有钱. You cannot say at the same time 你没有钱. Contradiction. Either one. So P and not P can only true for one statement. Okay, cannot be both true. Okay, so this how to solve this problem? So what's the problem here? The problem here is I didn't specify where the S come from. I didn't specify where this S come from. Where to pick this S. Okay. So one moral you can learn here is there's no universe. There's no universal set. So if you see from your SPM question, that gamma is a universal set. Something is wrong there. Some logical thing is wrong there. Okay, so there's no universe of set. Nothing contains everything. And we can only put the condition on a appropriate set. Okay. So we need to specify where we pick the S from actually. Okay. Although in set theory, right, we don't have the universe, we can go beyond set theory. Okay, there's something called Grothendieck universe. Okay, yeah, you can do universe somewhere else, not here. For example, you can do universe in category theory also, okay, but not in a set theory setting. Okay, you cannot do universe. All right, so let's continue. So instead of defining what a set is, we would just say about the membership of a set. Okay, I will just tell you what is inside the set, that's all. So instead of defining what a set is, we will just talk about the membership of a set. Set. Okay, so let's put a definition here. So we will write a little s in S, okay, if S is an element, set S. Or we will just write S slash the element sign, capital X, otherwise. Okay, so this notation here really resembles E. Okay, it's like an E, small e here, because this is element. Okay, try to make these connection as many as possible, because you cannot remember all of them. Okay, what you can remember is how they come from. Okay, how to make sense of them. Okay, sometimes we will write the other way around. So sometimes we'll write S containing S. Okay, write the other way around. So this will represent an English sentence. So this represents the set S contain the element S. Okay, so for mathematician, all these symbols actually mean some sentence. So it's pretty important now when you write some symbols down. It actually is a sentence. Okay, why this makes sense here? Because actually this is how ChatGPT works, right? This is how computer works, right? You just put a bunch of symbols. Okay, 10101000, but it output a sentence. Okay, so it makes sense that they are bijective actually. Later we'll talk about bijective again. All right, so now we have defined set, right? So we should talk about when two sets are the same. So two sets as T are equal. What do you think? How do we define two sets are equal? When are two sets equals? What do you think? They have the same element. Good. So how do we put this as a symbol? How do you check they have the same element? So that is for every x, okay, if x in S, if and only if S is in, okay, sometimes we call this axiom of extension. There's no reason why we want to make it like that, but we think it's useful, so we take it as an axiom or definition. Notice that when I write these down, right, I didn't say where you pick your S from. Okay, so a better way to put this is write the condition is for every x in S, we need to show that we need to take every S from S and then show that this S is in T. And for every S in T, we take it out. We need to prove that X is actually in S. Okay. Okay. Yeah, but if you write like this, I also understand. But to be confirmed, actually, this is what you need to check inside your proof. You take anything from S and then check that it is in T. You take everything from T, check that it is in S. Okay. All right, so this is about two set is the same. Next, we'll define subset. We'll define a bit of terminology before we put things together. So a set S is a subset of T. Another set. Okay. What's the idea of subset here? Can you draw me a diagram? What's the idea of subset? Okay, you have a big T, a small S inside there. Okay, so what does this mean here? So to put into a membership condition here, if every element from S actually is an element of T, correct? Because you stay inside a bigger circle, right?
So everything in S should be in T. Okay, very intuitive. For every S. S in S implies S in T. So what did you notice here? I put two definition here. What did you notice here? There are two different words, right? One is about equality of set. One is about subset. Can you look at the condition? What's the difference here? In the subset definition, there's only one implication, only one way. Only one way. I don't know. Equal, you need to go both ways. Okay, so this is the difference between equal and subset. Okay? Yeah. Oh, thank you. So here is a little x, not x. Otherwise, doesn't make sense. If I put something like this, right, it doesn't make sense. So where's the small s come from? Right, so this is one way to check if right makes sense. Okay. So after define this, we're gonna define a proper subset. Okay, a set S is a proper subset. A set T. Okay, let's denote it by S subset T. Okay, without the equal sign there. If S is a subset of T and at the same time S is not equal to T. So sometimes you will see in the books, right? They will write S subset not equal to T of them. Okay, cancel the equal sign. So far, okay. Okay, so what do you need to do for these two conditions here? For every element in X, you need to show that it is in T. How about this one? Not equal. There are some element in T that's not in S. Okay. So you need to produce some element. Right. Okay, so first thing, we're going to prove similar to AA. In the AA first class, right, we also proved this. So there exists a unique set with no elements. And then this is called, what's the name of this set? No element. Empty set. Okay, so it is called the empty set. Right. So how to prove this? So there are two things to show here. Existence and uniqueness here. Okay, there are two things to show. Existence and uniqueness. Which one we do first? Existence. Okay, let's prove that it exists. How to construct this set? What do you think? How to construct empty set? So in the A class, right, we also construct empty set, but that time our set definition was a set is a collection of elements. So it didn't mention about the collection is empty or not. So you can take empty collection. But now we don't have set definition. What we know is how to talk about elements inside the set. Okay, so how do you use the condition that you can impose in your set to give an empty set? Think about it. Maybe one direction you can think about it, if we give a condition, but no one satisfied, right? 对吗？怎么有些人找不到男朋友、女朋友，怎么找不到啊 ？Condition 太多了，是不是？没有人能够符合。Cannot satisfy the condition that you give. Can you give a condition such that nothing is inside there? Yeah, you just use the Russell paradox. That I don't know. So we define proof or let A be any non-empty set of R. Just pick a subset of R. So we can construct an empty set using a similar to Russell paradox example. So this empty set will be everything from A such that A not equal to A, X not equal to X. Okay. Similar condition from the Russell paradox. I mean, for every real numbers, right? What am I writing here? So why change my word? So for every real numbers, right, it should satisfy an equivalence relation, right? Okay, 2 is equal to 2. Okay, if 2 equals to 2, if 2 equals to 4, I mean, okay, I don't want to say other relation, but 2 must equal to 2, right? Every x must equal to x. So there's no numbers that satisfy x not equal to x. Okay. Does that make sense? Make sense, huh? Yes. Go outside, huh? What do you mean? Complex number. Sure. Then you need to construct something else. You need to give some other condition that cannot be satisfied. Correct. Why we pick this is just some convenient choice. Not again in pure maths class. Maybe some of you very confused is why I choose this. Why I choose this. It's just basically it works. That's all. You can choose other thing that works. You can think others idea one. You can create other. For example, what? For example, if we learn intersection later, right? For example, 2304, okay, and 2309. If you take the intersection of these two sets, obviously empty, right? Because these two are disjoint. So you can create empty set from intersection, for example. However, learn intersection yet, so we construct an empty set just using membership. So the idea was basically create a condition that no one can satisfy. 对吧？对不对？你要长姜高加美长头发戴眼镜会煮饭，找不到啊，找不到。Cannot. You cannot find a condition. Find a condition that no one satisfies. Okay, so this proved that what?
This guy thought his girlfriend is empty.
Okay, so this proved that no, my girlfriend is a mess. Okay, so this proved that the existence of an empty set. Okay, this proved that the existence of empty set. Okay, how about uniqueness? What is the general technique for uniqueness? Good. So for uniqueness, suppose there are two of them. Okay, suppose there are AB with no elements. Okay, so suppose there are AB with no elements. There are two sets. No elements. And then what do? We want to show that A equals to B. Okay. But what is A equals to B just now by definition? Two things to show, right? What's the two things? Definition give you what? That is, we want to show that for every x in A, x is in B, and for every x in B, x is in A. Okay. But there's more easier notation for this, right? So one is, okay, so this is equivalent to A is a subset of B and B is a subset of A. Like that. Correct? We split into two directions. Okay, then this two direction is also called a subset. Okay. Right. Should we do this? Let's do one direction. The other direction is symmetry. So let's do one direction here. 来，给适应选一下。
所以现在就要抓起来啊，不然会不见了。OK，来选一个方向先。Yes。一还是二？啊？
左边去右边，左边去右边。OK，选一啊。OK。So let's first prove A and B. Okay. So what do you need to do?
You need to show for this universal quantifier, right? So if you want to show for universal quantifier means what? You need to take any
X in A. Okay, so you take any X in A. You want to show that X is in B. Okay, good. So what's this statement here? So what's the statement here? For any X in A, want to show the X in B. So in other words, let's put it down again. Clearer like this. For every X in A, X is in A implies X is in B. Okay, so you need to prove this implication. So let me write down the word. We need to prove the implication. But what is A? Yeah?
Since you take something from A, right, you need to ask yourself, what is A? What is A? A is empty set. A is empty set means what? Nothing is in there. But you tell me there's something in there. Meaning what? S in A is false. Okay.
So this thing is false.
But this is a statement of P implies Q, right? So if P is false, no matter what is Q, everything is okay.
Since X in A is always false, then the whole statement, the implication, the whole implication is true. So hence we have A is a subset of B. Okay. So the other direction we will left for exercise is the same idea. And the other direction is the same. So for the other direction, B in A, it is similar. Okay. So actually, before coming this class, actually I assumed some logical what? I assume your first propositional logic is good. Okay. If it's not good, I put out my MA notes for you to refer back. Okay. Yeah. Sorry.
I don't think make
I also don't think so. I also don't think so. Yeah. Okay, but if you want to refer, you can refer back to my MA note. I put it into the Moodle also. Please tell me. Okay, I will put a version up there if it when it's done. Okay, so next theorem. For every set S which is not empty, we will have that phi is a subset of X. Okay, so now let's take some time. I want you to discuss with your friend. Okay, try introduce yourself to your friend beside you, behind you. Then try and discuss. I give you about 5 minutes. Okay, see how to prove this. Think about this. Okay, how to prove it. And then discuss with your nearby friend. Okay, it's very important to make friends in this class. You need them for assignment. Okay. Yeah, think about this question.一样咩？
因为你已经有上升3点
啊，
代表
哦，yeah. Subset 是 vigorously true, yeah.
这是就和那个是
啊？不一样啊！你跟他为什么不一样？他有的东西你没有。对。
宝宝上次我弄那条件是
第一个
哦，是你的，还因为没分析出来。
啊，
从80这边分可以去听，
用了。
这个重要。
Okay, let's get some answer. Know how? I know how. Try. I know how. Try. Same as the previous one. Okay, so how do you start? Yeah, how do you start? Similar idea. Yeah, but how do you write it up? So you need to prove for universal statement, right? So you need to start from what? Take any set. That is non-empty. Okay, and then important, very important in my class, I want you to get is always write your goal first. Okay, what do you want to show? Okay, write your goal so that you don't get lost. What's your goal? Okay, my goal is I want to show that empty set is a proper subset of X. And then you start to ask yourself, hey, what this notation means? Or what this notation means? That is, P is a subset of X and P is not equals to S. So this is the two things you need to show. Okay, so let's do the first one. For P is a subset of F. So what's the definition? We need to show that what? For every S in empty set, S is in S. Is this true? Right?
他们怎么感觉问答案？来， 跟我讲一下，为什么你换答案？啊，为什么换？
因为我刚错了。
啊，不要紧，就 OK，可以没有问题。所以为什么这个是对的？如果你换答案，为什么对
Well, I mean, 这个 this has another incarnation, right? For every x in phi, x is phi implies x in phi. 对吗
？OK， so why this is correct？ 你点头嘛，对不对？
Yeah, so you need to prove a P implies Q statement here.
P implies Q 啊，P implies Q 有几个 technique？OK，either P is true, Q has to be true。还有一个 technique 是直接把你的 condition 变 false， 这句话就成一定对了。OK，as long as we call this a necessary condition. As long as your necessary condition is false, right? Your whole implication is always correct. It's always true. Okay, this is the first proposition logic. So in this case, what do you see? What does this necessary condition hold? Does it hold or not? S in empty set. True or false? 啊，小童 true or false? S in empty set. 有东西吗里面？没有啊。Okay, so this will be always false. Okay, false implies everything. Okay, yeah, no, okay.
So, since x in P is always false, then the above implication is true. So P is a subset of every non-empty set. How about not equal 呢？我要选另外一个，选谁啊？一星，一星。How about for x not equal to 来，
为什么不等于啊？想想看呢，想想看想看什么东西？这么 Jack 跟那个罗浩不等于啊？不一样吧 ？OK， 不一样吧？可以。但是我们就从你们身上开始读吧。你看，罗浩有戴眼镜，不要什么？不要矮，喂，不要这样。罗浩有戴眼镜，那个 Jack 没有戴眼镜，对不对？一个眼镜在罗浩上面，在 Jack 上面没有眼镜，所以能够找到一个东西是对方没有的嘛？对不对 ？X 跟 empty set 这样想找一个对方没有的东西。How to find x not equal to empty set 来看 empty set 有东西吗 ？S 有东西吗？有，是不是
Okay, so since S is non-empty,
我不知道什么东西哦，它就有东西罢了。
we just take a little s. Okay. But
我能够确定呢，我不管是什么东西，
I can confirm that whatever I pick from x,
为什么？
x is not in the empty set because empty set has no element. Okay 吗？
对吗？所以 in this class sometimes 你不要 confuse 你可以选东西，但是你不知道选什么。You can pick an element, but you're not sure what you can pick. It's okay one. It's okay. It's a choice. Yes. Later we'll see axiom of choice also. 你可以做决定，你可以做选 Yes. 什么意思啊？
You really write S not equal to empty set on your question.
Okay, sure. I mean, in English, sometimes we will say it is non-empty, but I put it in the mathematical form then you will see that it's very obvious, because sometimes you will see it like this. Okay, but mathematically it means not equal. But obviously there's some syntax problem here. I mean, we need to address.
So I mean, one lesson I want to teach you is how to go from English to mathematics,
And then come back. Okay. Okay. Why I can write the not equal sign is because exactly I can find something in S which is not in the empty set, because empty set has nothing. No matter what it be, it's not there. Okay. Question? No. Okay. Yes.
Here to find the empty set instead. So here,
Can we use this to define empty set?
Oh, the set contain all set, huh? One way to talk about this is about using intersection language. Intersection. Otherwise, how you argue? Maybe can also go. You should go through intersection language because it has to be the element that is in the yes. Okay. Anyway, all of you know what he's saying. Hey, that can you repeat again?
can we use this theorem to define the empty set instead?
Okay, so can you go precisely how you define it?
Define the empty set as a set that's contained in all other sets of it's a subset of all other sets.
So define empty set as a subset of all set. Yeah, you can. Okay, actually there's a one clean way is to use the intersection. Less arbitrary.
Just now the first have to pick a random set.
Sure. But the point is, do you see the similarity between these two construction? Is to create a condition that no one can satisfy. This is the whole point. Let me tell you another story. For this sort of analysis proof, right? Analysis topological type proof, right? Sometimes it's very constructive. Yeah, this is something you need to get use of it. It's very constructive. So meaning maybe you can construct another highway to the same place. Okay, it's different from algebra. It's algebra, we only throw definition and then the result will come out. But for this type of topological analysis proof, we will be very constructive. Because why? Because actually topologies came from analysis. And later you will see when we introduce continuous function, you will see how we transit from epsilon delta to open and close. Okay. Yeah, sure. I think this is good. Okay, you can define an empty set this way. Yeah, because if you want to check an element that will satisfy all of the relation, then it should be empty. But I think this requires some work. So I mean, yeah. Okay, so it requires some work to prove. Okay, so maybe homework, you can try and work it out. A very good question. Maybe you can come out with it. Okay, next. Next, so how do we gonna play with set some more? So we'll define power set. Okay, so what's a power set? So we'll define it as PS. S. Okay, is the set. Okay, now we're talking about subset, right? So this is a set that contains all subset of S. So I think you do this kind of exercise before, just that we make this language into PX. So for example, let's do some examples here. Let's consider the power set of two element set 1, 2. So what are the
subset here. Can you give me some? Maybe one by one. Zhenyue give one. Yeah, subset. Contain what set containing one? Good. How about Hangwei? Good. Very symmetry. Ethan? Good. Just now we just proved right. And this is a subset of everything. What else? Ian? Containing 1, 2. So this is the whole set, right? Okay, so basically, these are all right. Actually, have you guys proved theorem or not? Elements in the power set is 2 to the number of elements inside the set. Okay, so in this case, it's 2 to the power of 2, right? Okay. Yeah. Because why 2 to the power n? Because you just need to decide whether this element is inside your subset or not. Okay, later we'll talk about cardinality. Okay, I want to refresh your mind. We don't start from completely new. So next definition, we know how to compare two elements, two sets. Now we want to combine them, okay, which is the union. Okay, so for example, you are the union of 2304 and 2309. So this class is the union of two classes. So the union of two set ST is the set containing all elements that are either in S or in T. Okay, when I put all here, right, is it possible that the element is lying in both sets? Is it possible? Possible or not? Possible. X is in S union T if and only if X is in S or S is in T. Okay, so this or is a V because this is a first propositional logic or. Yeah, I put a V here. And then this or is a U. Okay, between two sets, the union of two sets is a U. Between the union between two proposition is a V. Okay, it's possible. Okay, if you fail in 2304, right, maybe you'll go to take same class with 2309. Okay, so it's possible. It's possible to stand in both sets. Sometimes we call this axiom of union. Okay? We just combine things together. So let's do something else. So next, we're going to define more union. Okay, not just that we can combine two sets, we can combine more sets together. Okay, but when we combine more sets, right, we want to start with some labeling. So let's I be an index set. Maybe you might be confused that I didn't define what is index set is. Maybe we'll define it rigorously later, but for now, you just think of it as some other set. Okay, why I call it index set? Because this is the purpose I want to use it. You know what's index mean? You 读过书本吗？课本啊 You move to the last page 有没有很多字跟号码在一起 That's an index page. So index, what does it mean? 那个号码 you have a word pair with a number. So you are labeling words. Why you are labeling words? Actually, index here mean labeling. Label, okay, labeling. Oh. Labeling. Right. You guys know that you are being labeled. 有吗？你们被标记啊，你们知道吗？一进来这学校的时候，你知道吗？呀，什么 ？Yes， 有student ID， 你已经被标记了。You already get labeled. Okay, so labeling set. And F is equals to the set of AI, okay, where I is the labeling set. And so we consider all these sets together. Okay, so why I can introduce this F here? So we're gonna define the union of everything inside this set. Okay, so I think there's one unnatural thing you see here is this F is a set, but this AI is also a set. Okay, so the elements are set. also. Okay, it's possible. And the union AI of all set in F. Okay. How do we define this? What do you think? How should we define this? Any idea? So we want to define this as a set, right? So how do we define set? Go back to the first page. We need to use membership. Okay, so now in your mind, whenever we talk about set, right, you need to talk about membership. So when you want to define a set, you need to tell me what is in there. What is in there? Okay, what is in there? Or tell me what are the elements could stay inside here. What are the elements can stay inside here? What is in here? Guess that. Just guess. See your intuition correct or not. If I want to combine everything in AI, right? So what is in here? Huh? What is inside here? Huh? For all x in F, like that. Like that. Okay. So let's test this. Closer. Or you want to add more? Close first? Okay. So let's test this theory here. Let's test this theory. So what does this mean? What is in F? What is in F? What are the elements here? AI. These are the AI. Is this what you want? Is this what you want? Okay. Maybe it's not clear. Let's take some example. Maybe I have 1, 2, and 3, 4 like this. Okay. And then we're going to define what is 1, 2 union with 3, 4. By this definition, right? What do we get? We get a set having 1, 2, and 3, 4. Is this what you want or not? Is this the union you want? Maybe you can do something like this, but I think we won't call this a union. Okay. Instead, what we want to do is we combine everything inside this set. This. This is very important concept. Actually, I tell you. This is a frequent people get lost here. Okay. Yeah, they will treat union like this. But as I show you this example, right? What we want for union is we just combine the elements. Okay, so how do you write this down? 1, 2, 3, 4. As long as this 1, 2, 3, 4 stay inside one of the set. Okay, so what we will write here is all the S such that S is in AI. Okay, for some AI in M. Like that. Okay. Okay, now. So union means we mesh things together. Okay, now. But again, example 2304 and 2309, two sets. I take union, clash into one set. So the general topology class is all of you. Okay, I don't split you anymore. Okay, so they combine into one set. Make sense? Okay, man. Okay, so I put a warning here. This is not equals to the set containing 1, 2, and 3, 4. Okay, this is not equal to this. Hey, can you see that these two is not equal? 看得出不一样吗？为什么不一样的字音？不然属先属先这边有几个东西 ？How many? Here got 4. Here got how many 东西 ？2. Yeah. And then you can look at these two elements, right? 长得一点都不一样。Okay, it's different, very different. This is a set of 2 elements. Here, just one number, 不一样。Okay, so they are different. Okay, so be right that you define the right stuff. Okay. So there's some other example I want you to see is
If we put the index set as n, okay, so we'll put the union as the union from 1 to infinity. Okay, like this, if the index set is n. And then if the index set is finite, okay, finite n here, then this union we'll write it as union from 1 to n. Okay, and then for R, okay, if like for uncountable set, later we'll define for R something like this, you cannot arrange it properly, you cannot index it, so we'll just put like this. Okay, so the reason why I put this example out is we will frequently deal with this kind of index set, and this is the way we write it. Okay, we got 2 more minutes. Huh? Okay, let's do one more definition and then we can call it a day. Oh. After union, what you do? After union, what you do? We do U, right? Then we invert the U, become N, which is intersection. Okay, so we define the intersection of two sets, S and T, is another set, okay, that contain all elements. All elements that are in both S and T. Both S. Okay, so this time we require it to stay in both of them. Okay, just now either one of them is okay. Now it's both of them. Okay, so that is for every X in S intercept T if and only if S and okay. So now maybe I test you up. So let's test it. So exercise. Let's try define the intersection of any index set. Any index set. Let's set index by any index set. What do you think? What should be in here? X is in AI for all I. Okay, so can you see what's the difference between these two definitions or not? Okay, so let me bring it down. Can you see what's the difference between these two definitions? Yeah. Why Lopez? So what's the difference between these two definitions? What's the difference? Only the last part is different. One is existential, one is universal. Okay. So this differentiate intersection and union. Okay. So how to differentiate union and intersection? You go back to first order logic. Okay, one is universal, one is existential. Okay, any question? We need to be on time. Yes. Yeah, sure. Well, if you want to write it, yeah, you can write this as there has this sum. Yeah, to be consistent also can. If there's some I in I that exists for sure, that AI also live in F. If you can find some AI in F, for sure it comes from some I. So depend on E. Any question? No? Clear? Very clear? Okay. Yeah, so before we, after finish, right, maybe the two class rep can see me for a while. We can talk about how to set up the team page. If nothing else, we will call it a day and then see you tomorrow.
James
这个是
James 做么？